So if you own a Commodore 64 or a Commodore Plus 4, you do a little bit of research online, the first thing you'll see is everyone will say, don't use the original power supply. This is down to the 5 volts DC. Over time, the voltage regulator fails, and when it fails, the voltage goes upwards rather than downwards. So with the voltage increasing above 5 volts, it starts causing damage first to the memory chips and then to other chips. Now you can buy a modern power supply which has a better 5 volt regulator, or a supply over voltage protector, which goes in line with your original Commodore 64 Plus 4 power supply, and will prevent it, if it does go over voltage, it will prevent it from sending that voltage through to your Commodore 64. However, the one thing I found with a lot of these options are they are quite expensive, and don't get me wrong, they're worth it. If it saves your computer, they're definitely worth it. However, sometimes they're not in stock, and plus also, when I look at my wallet right now, I'm thinking I've got a Commodore 64 power supply, I've got a 5 volts DC power supply I can use, I've got a 9 volt AC. Let me see what I can make out of the original. However, things don't necessarily go according to plan, as you'll see. So just bearing in mind, we are dealing with mains voltages here, so if you don't feel comfortable with it, by all means watch the video, but don't try and attempt it yourself unless you feel comfortable around mains voltages, and also just be very, very careful. As I say, this is more experimentation just to see what I can do with the existing Commodore 64 power supply. Got two Commodore power supplies here. One's an old style power supply and one's a newer style, the one that come with the 64C. Now you see the black one there is 9 volt AC 1 amp, 5 volts DC 1.5 amps. The white one is 9 volts AC 1 amp but 5 volts 1.7 amps. Now the ampage itself doesn't make a difference, the Commodore will only use what it needs to use anyway. So I've gone for the black power supply first, and I've been told the best way to do this is to start trying to prise it where the leads themselves come in. And what I'm doing here, I'm pushing upwards on the screwdriver rather than down, just to try and force it away. Now this is usually glued together, this part, and so it can be a little bit tricky to get it to move, but after about 20 minutes it started to show signs of giving way and coming off. So if I can just get this lid off here, I'll show you the next problem we have with these power supplies. So while I'm doing this, I'll just explain. The 9 volt AC on these power supplies tends to be fine. It is the 5 volts that gives the problem. And it's quite unique in that a lot of power supplies from this period either were AC or DC, but rarely you would get AC and DC together in an 8-bit power supply. And that's the problem. The transformer itself there, as you can see, is covered in a resin. If you're lucky, some of these don't have that resin in there, but basically every single one I've ever opened up always seems to have that resin in there, and it is an absolute pain to get your transformer out of there, even down to trying to get the leads out as well. So how this power supply works is it takes a primary voltage of 230 volts AC here in the UK, or 110 volts AC in USA for example, which then gets transformed down to two 9 volt AC outputs. One of them 9 volt AC outputs goes directly to the Commodore 64, and the other one goes to a voltage regulator and a bridge rectifier to turn it from 9 volts AC into 5 volts DC. Now if we look at the pins there, we can see on the old style power supply they've just used the pins they're actually going. So them top two pins are the 9 volt AC, the bottom pins are the 5 volt DC. On the more modern one they've used, looks like just an off the shelf kind of a connector. So a lot of them pins aren't connected, it's literally only them 4 pins that are connected anyway. So with this white power supply, and you can see I've written on the bottom there, for some reason the 5 volts wasn't working on this anyway properly. It wasn't giving out enough of an output to be able to run the tape drive for example. So here it looks like the lid is free, but it's still being held on by something, and I realised later there's pins that actually go into the resin. I think that's what was causing a bit of resistance. And this one, you can see they've completely encased everything in that resin. Also, unlike the black power supply, which has a fuse built into it, this one doesn't. What's making this an absolute pain is trying to get these leads out. All I want really is the leads and the transformer out of this one. As you can see, that didn't go well. Most of the leads come out, but that white lead was just buried under the resin. Mains lead came out alright. Then it's just a case of trying to bang this thing out and actually get the block out. So the best way I found is just go around the edges with screwdrivers, try and prise it away, because at the end of the day that compound's been in there now for about 35-40 years, and it is a little bit tricky, but once it goes it does tend to come out in one complete chunk, which is good. But again, you're talking about 20 minutes, half an hour to try and get this to start moving, but once it starts moving it comes out fairly quickly. And as you can see, you've got a nice block there of resin. I'm just going to have a look at this case. And you can see where it's been glued down on the side, some of the plastic has split a bit. But it's still in good enough condition to do what I want to do with it. So now onto this black one. So again, I can remove this board, the voltage regulator board. So looking at that board, it's very simple. You've got the 4 diodes for the bridge rectifier, then a smoothing capacitor, and then in that resin there, I don't know if you can see it, but that's where the voltage regulator is, and they've just buried it in that epoxy. So this one was a lot more difficult to get out for some reason. You can see here I'm banging away with it, didn't want to move really at all. Tried using a hot soldering iron and then realised that this stuff is obviously a little bit flammable, so I thought I wouldn't try that anymore. And eventually just brute force and ignorance and just using screwdrivers, eventually I did get it to come out, thankfully. So again, after a bit more forcing it out with the screwdriver and then just generally wiggling it, I managed to get that one clear. So again, when it does come out, the good thing is it does leave a nice clear case. So if we compare the two blocks here, we can see, so the grey one to the right, that's just got my transformer in it. The one to the left has got the transformer and all the voltage regulator. So to get these transformers out of the resin, I went for the percussive method.
We are the warriors of the dawn. With hearts ablaze we stand strong. For silence leads us through the fight. In unity we seize the light. We seize the light.
Again, this isn't recommended because chances are you're going to damage the transformer, but I just wanted to get it out just to see what it looked like really. So back on the table here we can see that's my transformer from the white one, and that other block of resin there is the what remains of the board and the resin above it. So this one I just tried to break everything out of here, but it didn't go well. You can see that little lead just dropped off, so that was one of the 9-volt AC leads. So right now it's just more of a salvage operation. I just want to try and get the leads out so I can use them again. The transformer itself, one of the windings, the actual winding wires was coming out. One of the mains leads broke off on it, and yeah, not much point in doing anything with it. So in hindsight, with the black power supply, what I could have done is just desoldered the board and just used another regulator in there instead. But again, this is the first time I'm kind of doing this, so I just wanted to see what both of them look like in comparison. So right now I'm only left with one good working, or what I think is working, transformer, so I just want to test it out. But you can see where I've dropped it on the floor now, it's got damages on the corner and stuff, so I just want to see whether this one's still good or not. So what I'm going to do is solder my 230 volt lead onto the primary side of the transformer so I can test it. First thing I'm going to do is check the plug. So in the UK, our plugs have fuses. Now this fuse in here shouldn't be any bigger than 5 amps, and some genius has put a 13 amp fuse in there, which is a really big no-no. So I'm going to put a 3 amp fuse in there. Basically, the higher the fuse ampage, the more damage it's going to cause before it blows. And this will become a bit more relevant later on, as you'll see. So if I check the windings there, I've got 9.6 volts AC on one of them and only 8.1 on the other one. So remember I said this is the one that had the issue. So this one was not giving out enough voltage to run a tape recorder. So it looks like the actual windings on the AC transformer on that particular side are starting to fail. That's why it's only 8.1 instead of the 9.5. So what I've got here is just a wall-wall USB supply. So this one's rated at 2 amps. And what I'm just using a hacksaw. I'm just going to cut the glue away for this one because we don't want to keep this casing at all. And split it open. So the idea is now I'm going to take 230 volts to this board, 230 volts to my AC transformer. AC transformer supplies a 9 volt AC, and this little USB thing will provide me with 2 amps, 5 volts. Now, because this is using more modern technology than the original power supply, it's got to be a lot more reliable. And by reliable, what I mean is when this one fails, it will fail to 0 volts rather than increasing the voltage up. So at the bottom there, that's where the live and neutral would connect to the plug, and obviously we're just going to solder leads straight to it. So if I get the power supplies out, I'm just going to have a look and see which one I'm going to use and which one it's going to fit best in. And I think for this, the white power supply is going to be more useful, because the other thing I want to do with this one is fit a voltmeter and ammeter into it as well. So with the black one, without having a smaller transformer, it's just going to take up too much room and it's going to be a bit of a crush at the front there. So with the square style one, it's giving me a lot more room to be able to fit everything in. So you can see this is the transformer originally sat in there anyway. And now what I'm trying to do here is just try it in different orientations, just see if there's a better way of putting it in this case. Looking at it, it looks like the original position is definitely going to be the best position. Unfortunately, the case isn't deep enough to stand it vertically. If it was, that would probably be a better position to put it in. And now I'm going to get my 5 volt board here. And you can see I've got plenty of room in there. Without the resin in the way, it's a lot easier. So this is a panel mounted voltage ammeter. So the idea is I'm going to mount this on the front of the power supply. So if there are any problems, I can start seeing if the voltage is rising or not. So to mark this out, first thing I'm doing, I'm just using a ruler here. And I just want to mark where the plastic finishes on the inside, on the outside of the power supply. What I don't want to do is if I cut the... because I want to put this voltmeter ammeter towards the top of the power supply, I don't want to go up too far that I'm actually hitting the top plastic. So I need to come down a little bit. And I come down about 5 mil for that. And then I'm just measuring up the actual meter itself just to see what size hole I need to cut. And again, for some reason I can't find a set square or whatever, so the best way I found is just do multiple markings with a ruler along your good flat edge, and then just join the dots up, and that'll give me a fairly straight edge rather than trying to guess it. The good thing is the meter I'm fitting has a bezel around it anyway, so if I'm a little bit out, it shouldn't cause too much of a problem. And so once I've found my centre point, I just want to come out either side for my width. And what I'm going to use, because this ruler is quite long and flat, I can use it to just butt up against the side and then just draw my lines upwards. So with that all marked out, the first thing I want to do is just make sure I've got my measurements right. So I'm just going to line up the meter itself on there just to make sure I'm not gone too big, not gone too small. It looks about right. So now I'm just using a little handheld cutter here, like a Dremel type of thing, just to cut out my hole in here. So that little split as well, I don't know if you can see it, there's a little split there. That happened when I was trying to prise out the resin. It'll become more noticeable later on, but you can see there's like a tiny little split. And again, that was my fault. It's where I jammed the screwdriver down and pulled it, and obviously it's quite a weak point in the case itself. So right now I'm just taking this hole out a little bit bigger to make sure the meter fits in okay. So if I push it in there, you'll see that little split at the bottom of the power supply as well. Again, it doesn't really cause a problem. This is more for experimentation anyway, just to kind of see whether this is all going to work or not. So that's our meter in place now. So next thing I want to do is, rather than use a USB, I'm just going on the back of the printed circuit board for this. So I've connected 230 volts to it, and you can see I'm getting 5.1, 5.2 volts out of here. So if I check with my meter, I'm using the top diagram there. So I'm not going to use the black lead on the meter because it's all coming from the same supply. So the next thing I want to do is just wire it up to my 5 volts and see what I'm getting. So when I turn that on, I'm getting 5.1, 5.2 volts. Perfect. I'm getting no amps at the moment, but I wouldn't expect to get any amps anyway because right now I'm not connected to the ammeter side of things. So the next thing I want to do here is test the ammeter out. And what I've done, I've opened up a USB cable, and you can see I'm trying to just charge a Kindle there. You can see the amber light on the Kindle itself, but on the ammeter, even though it's connected correctly, I'm not seeing anything. So what I'm going to do is put my multimeter as an ammeter as well to see whether that's reading anything. I have a feeling what's happening here, the ammeter is the amount of amps being used are just too low for it to read. So you can see when I put my meter in line as well, you can see the little charging light coming on that Kindle. And the way an ammeter works is it goes in series rather than in parallel. So when I take it away, it obviously breaks the circuit. But it's reading it, but obviously, so the actual meter on the power supply right now is not showing me anything, but I just think it's just down to not having enough amps to be able to show anything right now. So next thing I want to do now is just wire the mains voltage back up to the transformer, which is then piggybacking onto that 5 volt supply as well. And now it's just a case of trying to get it all to fit in there without putting any leads or anything underneath it. So if I push that down into place. And the other thing I've noticed with this grey lead, you see it's got a hole at the top or a kind of divot in it. That seems to need to be facing upwards, and then it slots in there fine. So that's it, that's in place, and that's going to sit nice and flush. I've got my mains lead going over to my 5 volt power supply here, my 5 volt DC power supply. I'm just wrapping a little bit of insulation tape around the black wire that's coming off of that ammeter because in the diagram I don't need to use it. Now if you look at the meter there, you'll see I haven't swapped the leads over from when I was measuring the amps. And now I'm trying to measure the voltage, but I haven't changed it, and it's blowing that fuse straight away. And at this point, I still don't realise. It's only when I do this that I realise I've put the leads in. I've got the leads in the ammeter slot rather than into the voltage slot. A little bit of fault on my part, and that wouldn't have happened. The fuse is definitely blowing, and again, this is why I'm glad I put a 3 amp fuse in there rather than a 13 amp fuse. A 13 amp fuse would have taken a lot longer to blow, and chances are it would have damaged the meter or damaged the power supply itself. So now I've got them in the right slot, I can test, and I'm getting 245 volts, which again is normal for the UK. Just testing my leads again, so I'm getting 9.5 volts AC there. And again, this one's just giving me around the 8 volt mark. So I'm going to be using the 9.5 volts legs. Next thing I want to do is just test my leads here just to make sure they're all coming to the end, which they are. I just made a little diagram of what colours are doing what here. So my white and yellow are my 9 volt AC, and my blue and red are the DC. So the red's my plus 5 volts, the blue's my 0 volts. Depending on what Commodore 64 power supply or plus 4 power supply you're using, this wiring of colours will be completely different. It's completely different on the other power supply, on the black power supply. So right now I'm connecting the 9 volts AC to the transformer itself. I just had to extend that little white wire as well. Connecting up the DC, and again this ammeter is now in line. That's why that red is actually a negative going to the negative leg of the 5 pins. And again, just to stop any shorting out, because we are dealing with 230 volts, I'm just going to wrap this in insulation tape for now, because again I just want to test it and see whether it's going to be a viable option or not. So for now I'm just going to wrap this in insulation tape just to make sure everything's nice and safe. I don't get any shorts happening when I'm in the case. And again, I'm completely mummifying this thing in tape, so we're not going to get any problems here. So next thing now is to just kind of slit under the wires. And you can see all them other little cables there that are wrapped in insulation tape. The reason for this is, again, just to stop anything shorting out. So that 8 volts AC, for example, I wrap the ends of them in insulation tape. Anywhere where I've done a solder connection, I've just used insulation tape for now. Because, again, this is very experimental at this stage. Just want to see whether it's a viable option or not. So, again, if I put this lid back on, another thing I want to do right now, I don't want to glue it together or do anything like that with it. But obviously I can't leave it as it is. So again, I'm testing the voltages here. So I'm getting my 9 volts AC. And then when I'm testing the 5 volt DC, so I'm getting 10.3 volts on my 5 volt output. It's really confusing me because the front of the power supply is telling me that it's giving out 5 volts right now. So that's really confusing me. I'm getting 5.1 volts there, 10.3 volts on my multimeter. Then of course I realised I still had it in AC and I wasn't measuring DC. So again, sometimes if you're measuring a DC power supply with AC, you'll get weird and wonderful readings. It's not giving out an AC, it's giving out a DC supply. So on a DC supply you can see there I'm getting 5.06. So that's all fine. Next thing I want to do is plug this into a Commodore, switch it on and see if my ammeter's working. And that's looking good. So you can see right now that's drawing 0.8 of an amp, this particular Commodore. So that all looks good. So again, I don't want to glue this together right now. So all I'm going to do is just use a bit of insulation tape, wrap it around it. So the idea here is if I need to get back in there, I can get back in there quite easy. I don't have to try and crack open any glue or anything. Because again, ultimately, at some point, I'm thinking of changing that transformer in there. Because it is an old transformer at the end of the day. So chances are that's going to fail fairly soon. Plus also, I wasn't the kindest to it, throwing it on the concrete like that. And also, at some point, I want to put in a limiter anyway. Just in case this particular 5 volt DC power supply does start rising in voltage. I want to be able to kill the power to the Commodore to stop it causing any damage. Just giving the power supply here a little bit of a shake test. just to make sure it isn't going to fall apart with just using the tape to hold it together. But that all seems good and nothing's really rattling about too much, which is also good. So now the final test here is to connect the power supply up to Commodore 64C, and you can see I'm at 5.1 volts and about 0.85 to 0.83 amps. If you're going to do this, I'd recommend using a 2 amp USB charger rather than a 1 amp one, because that's going to be very close to the mark. So depending on what's plugged into your Commodore 64 or Plus 4, depends on how many amps it's going to use. So for example, when I plug this cartridge in here, you can now see the amps have gone up to 0.89 amps with a cartridge in there. But that said, it all looks like it's all working nicely. The only thing left to do is play some Commando. So with that, I will see you on the next one.
We are the warriors of the dawn. With hearts ablaze we stand strong. For silence leads us through the fight. In unity we seize the light.